Okay, it is officially Monday. It is almost the end of September, nearly October. Bananas, bananas. Although the weather is very much feeling like it's the middle of fall now, so I guess we're going with it. All right, so today we're going to continue on the multiple regression.
I'm in class right now.
But you're not muted. Aha, gotcha. Okay, so here we are talking about multiple regression, continuing on from last week. Now, the first thing I want us to do is this cartoon I provided to you along with some of your readings about the extrapolation in multiple regression. So the first thing I'm gonna do is put you in groups to go through your reactions to the multiple regression cartoon and the readings that you had on this subject. And so what I'd like for you to do in this activity first is to say hello to your Zoom mates. And then I want you to use this cartoon as your base to draw a plot to represent the relations between these two variables. And those two variables are what you will first talk about. What's the X? What's the Y? If you don't know how the constructs are measured, that's okay. You can make something up. You are the maker-upper of things today. Sure. And then what I want you to do next is write your example of what you think a regression equation like this would look like. So use this to talk about to guide your discussion around any fuzzy points that you had around what multiple regression is or what regression is in general based on your readings from this week. Okay. While I'm pulling up the information that will put you into breakout rooms, feel free to chat or ask out loud any questions that you have. Okay, here we go. And then I will randomly drop into your rooms in a minute. How many rooms do we have? We have 10 rooms. Okay.
Yes, I think that was the cartoon. Hi, Dr. Logan.
Oh.
Hi, Dr. Logan.
Hi, how are you?
We are doing okay.
That's a dumb question. Let me ask again. Did you all say hello already? How about that?
We did say hello. I think Christy doesn't have audio right now.
Oh, sorry about that, Christy. That stinks. Do you have access to this PowerPoint? Probably not. I think I realized I didn't have it shared. I just hit publish like right before I logged on, so I can share it with you if you can't see it yet.
Okay, I'm gonna get in there and look and see, because that'll be good to be able to follow along on that.
Okay.
Oh.
I haven't pulled up
cool.
here.
Thank you.
Oh, thank you.
Yeah, you're welcome. I'm sorry about not putting it up in time. Okay, so the first thing that I wanted to do is think about the relation between these two variables. So what is X and what is Y?
Okay, so I draw a graph. I'm not sure if you can see this.
Yeah.
So I just made it up. So x-axis, for me, I think x-axis will be time and y-axis will be like love or affection or anything. Yeah.
That's what I was thinking too.
Yes. So as time goes by, the love emotions will increase. But like this cartoon says, she hated you before you met. So maybe there will be some negative values for y, y value. So yeah, before it's kind of interesting.
Uh-huh.
Yes.
It made me laugh a lot. Why is she scowling at me? So then let's think about it this way. Now that you have that plot, and Hadley, it sounds like you have a similar plot, is
Yeah.
that what is the actual range of observed data? So look at the plot that you made and imagine, like, where have you actually observed any information about this relationship or the relationship between love and time?
So where in the comics did we observe that?
Where on your on your plot that you made up,
Uh-huh.
where would you have observed?
So I'm kind of struggling understanding this cartoon. So she's kind of frowning.
Uh-huh.
So is this the time that she hated?
Yeah, this would be the time that
Ah.
she hated him when she didn't know him at all.
Ah, I see. Okay.
So let's maybe on that plot, maybe you can draw a line of when they
Mm.
meet. So if I say, here is when you met. And this is amount of affection on the x-axis, which you can't see what I'm doing, so I don't know.
So if she hates him, would when they met be like in the, well, I guess not in the negative because I'm not seeing like a 4-quadrant graph on yours.
Oh, true,
Okay.
good point. Let's make a 4-quadrant.
Because if it was it would make sense for it to be in like the bottom left-hand quadrant when they met, if she's hating him before, or maybe they met like right at the intercept. I don't know.
Yeah.
Yes, I did the same thing, I guess.
Yeah, that makes
I
sense.
guess.
And so if you observed, of course it doesn't, you can't actually hate someone before you meet them, which is part of why
She
this
does.
is,
Oh, yeah.
it's part of what makes
I
this so
mean-
ridiculous.
I could argue with that. You could hate somebody before you meet them. I can think of some people I have not met that I don't like.
That's a valid point. That's a valid point. All right, then. So within the context of this, so I think that this sort of drew a parallel to the other extrapolation cartoon I had for you, which was yesterday you had 0 husbands and today you have 1 husband. You should go out and buy bulk wedding cakes.
Mm-hmm.
Do those two things line up? Like, do the connection make sense?
It did to me, yeah. I mean, I was thinking about, I think it made sense to me about the concept of centering and why that makes more sense than like a simple linear regression that implies that the line continues in both directions, because it doesn't always make sense that it would continue in both directions.
Mm-hmm. And so within this context, it's a little less clear because maybe you can hate someone before you meet them, but certainly sorry, I got a little bit distracted there. Certainly, if you want to draw any inferences within a regression, you want to make sure that you are you're drawing inferences within the actual observations that you've made. Mm-hmm. Does that make sense?
Yes.
Cool. All right, I'm gonna go drop into another random breakout room and I will let you all come up with an idea of what that regression equation will look like.
Cool.
And probably like 4 more minutes, I'll pull us all back.
Okay, thank you.
Yeah.
Thank you.
Okay, bye.
He will be running at the speed of light.
Right.
Hi.
So we were.
Yes. Eventually, if you just go long enough, you will be running at the speed of light. How long will it be?
Right. That's so funny. We were comparing this cartoon sketch to the article about the Olympics and just the limitations that regression has. Our answers for this, I think our X was time, and then our Y was like emotion levels in this. And so we drew this here.
Uh-huh.
But we were just comparing it because we knew that like there's just other variables that aren't considered when it comes to regression. In this instance, like the psychological limits of a person, as far as their increased moods and decreases in moods. And how do you really quantify that? Was a question that we had as well for why.
That's a great question.
Yeah. Um, but yeah, so we were comparing it to the Olympics as well, and with that one, there was physiological limits when it comes to how fast each gender can run and the capacity for that. I was thinking about it in the homework, and I guess I'm like, if you were to look at like the year 3000, wouldn't the second be down to about 1 second through on the 100, right?
Yeah.
There'll be negative seconds at some point. It just wouldn't make any physiological sense to do it.
I like your speed of light. That's a really
Yeah.
eventually we're going fast. We're so fast we're defying all physics.
That's hilarious. But yeah.
So did you see, so it sounds like you saw the connections between the two cartoons and the reading,
Mhm.
and how those sort of relate to one another in terms of what regression can and cannot do. And maybe they're right. Actually, if you look at that article, it was published in 2016, I think. So there has been another Olympics since then that we could theoretically pull data from and see if it continues on that trend.
I'm trying to think. I competed at the Olympic trials in 2016.
Shut your face. That's so
Yeah,
cool.
I was a sprinter. That's why I kind of laughed when I saw the video. I mean, I saw the article. Because
Oh my
I've seen
gosh.
those fastest sprinters before. It's incredible. But I think that year the men's 100 wasn't that particularly fast. Usain Bolt is not running at the same speed as he did. They called him Lightning though, so.
Wow, that's amazing. All right, I'm going to pull us all back into the room. Thank you for sharing.
Awesome.
Okay, hello. It seems like maybe that didn't quite go as well as I expected. I kept seeing people saying they weren't joined. Was anybody totally alone? That's a no. Okay, well. So the, hold on. I love you, I'm teaching. Okay, so the reason I wanted you all to look at these cartoons and read the reading is because, remember, one of the objectives for this course is for you to understand what regression does and doesn't do. And so as you look at the, as you think about what regression can do, you can absolutely interpret relationships within the observed range of your data. But what the two cartoons and the reading sort of highlight is the fact that once you get outside the range of data, it starts to become problematic. And in breakout room 7, I think it was, you all were talking about how with the Olympics trials, if you just extrapolate out far enough, eventually folks are running at the speed of light, which is clearly not going to be possible. Also, someone's not going to have 3 husbands the next day. So if you, anyway, that was sort of my high concept, real big point of you understanding what regression can and cannot do, was thinking about extrapolation. So as you're thinking about within your own concept, your own analyses, this is one of the reasons why I want you centering your variables, is so that your 0 point is somewhere within the observed range of data, so that you're not, for example, talking about people running at the speed of light accidentally, because that doesn't make a lot of sense. All right, and that's going to continue on as we talk about multiple regression. Now, before we do that, I saw that we took the quiz, and thank you very much for taking the quiz. And in the interest of time, what I'm going to have us do is open the floor to ask questions about the answers from this quiz. So I saw several people took it today. A lot of you took it over the last week, sort of interspersed, but if you have anything that you got wrong or that's been bugging you, I'm gonna give you like 2 minutes or so where I'm gonna just be silent. And you can think about what questions you had about this regression quiz, and then I will answer those questions. Okay, then I'm gonna move on from this because we got one about question 7. So let me pull up question 7 and see what it is. Actually, can you tell me what question 7 is? Anyone who has it up?
I can. Yeah. Can you hear me?
Yeah.
Okay. So it says students in physical mathematical sciences have a different number of expected presentations than students in the humanities. What part of the regression output tells me that? And it gives 3 options. I was curious to know why it wouldn't be the second option or the third option, knowing that the B's are different. Could I conclude that from the second option and also the third option?
Let's see. The place where you get this information is explicitly in this contrast. The mathematical sciences is this one, physical and mathematical sciences.
Mm-hmm.
And this is the contrast between physical mathematical sciences and humanities specifically.
Right.
Everything else, the R, the ANOVA, and this SBS, well, the R and the ANOVA are about the model in general, which is just generally, are there differences in the number of presentations due to the program that they're enrolled in? Whereas this coefficient specifically is about the relationship or the difference between physical mathematical sciences and the variable that's serving as the reference group, which is humanities in this one. And so in this case, the only one that speaks about this specific contrast is that coefficient. Everything else is about the model as a whole.
Okay. Okay, thank you.
I saw another one. Yes, I'm referring to the multiple regression quiz. I should have made that clearer. Thank you. Last thing I have here is on the last question. Javante, if you still have that up, can you tell me what the last one says?
Yeah. Question 8, it says, what is one more observation you can make about these results?
Oh, yeah, that's right. I remember. That was, the reason I wrote that question is because I came up with about 12 other questions I could have asked you. And I couldn't decide. And so you could have said that the physical mathematical sciences is different than the humanities. Or you could have said that the expected number of presentations made at regional or international meetings for someone in social behavior sciences is 3.6 minus 2.3. I don't actually know what that is. 1.3-ish. Thank you. I appreciate it. Thank you, Shantanu. You got my back. So that's all I meant on this one, was just pick another thing you could say about these relationships, about this output, and write it down to give you practice with looking for information from these outputs. Okay. So now let's move on to multiple regression, where we don't have just contrasts of one specific predictor. We're getting more complicated. Here we go. All right, in multiple regression, we did our first example last week. We called it multiple regression, and it's called multiple regression because we have multiple predictors. Yes, I thought I was sharing the PowerPoint screen. Now I understand why that wasn't making any sense, what I was just saying to you. Here, I typed those questions and the answers in this PowerPoint screen that I did not share with you. So sorry about that. I saw somebody snarking today about how people are always like, can you see my screen? But this is why we do it, is because sometimes we forget. Okay, here we go. Dun, 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 dun. Whoops, I clicked the wrong button. All right, usually in regression, remember at the very beginning of this, I was saying the cool thing about regression is that at first it's pretty much exactly something you could have done in a t-test or in a correlation, but it's going to get more complicated. Stick with me, my story gets better. So it's very rare that we really are only interested in one independent variable. So we're going to look at multiple independent variables. In multiple regression, we'll use a formula to calculate the relationship between one dependent variable and multiple independent variables. And this multiple regression is going to allow us to investigate the effects of variables, of specific variables that we're interested in, while we are controlling for the effects of others. Now, I know you all have just been looking through regression papers, so you've probably seen the words controlling for or covariates maybe. So that's what this is about. With multiple regression, you're able to control for or hold constant one predictor while you're looking at the effects of another. And it does it automatically, and I'll show you how it looks. So here's some examples I pulled together of what multiple regression research questions might look like. So one of the things I study is reading comprehension. So one sort of research question you might get is, I want to examine the unique contributions of listening comprehension and word reading in the prediction of reading comprehension. So both of these, listening comprehension and word reading, those are both predictor variables, and reading comprehension is my outcome. Here's another example. It's library use. I'm going to estimate whether age and socioeconomic status are related to frequency of library use. Library use frequency is my outcome, and both age and socioeconomic status are my predictors. And we have something similar here with job performance. I'm going to look at job performance evaluations and personality test scores to predict how long a person will stay employed. So I'm going to walk through an example for you. This is, I said it's called example publications 2, but I'm pretty sure it's the same as the data that it's called salary in class, and it's uploaded to your Carmen, whatchamacallit for this week, your Carmen module for the week. All right, so I'm introducing a new variable to that idea we've been looking at about the relationship between publications and years of experience, or years from PhD. This time I'm going to introduce the variable salary. Now I just want you to remember that these are fake data that were made up sometime in the 90s. So they do not represent reality. So this is the example from the Cohen textbook. This is 15 people, publications or pubs. Sometimes I call it pubs throughout just for shorthand because publications is a really long word. It says publications in this column. Time is the number of years from PhD, and salary is in dollar amounts. Like here's a person making $18,000 a year. All right. So in a multiple regression, we're going to take multiple independent variables and use them to predict one dependent variable. So I'm going to look at how number of publications and number of years of experience are both predictive of salary. Now, if you remember from our individual regressions, the goal of a regression is to get one predicted y-score for every person in your data set. And you'll get it based on values of your predictors. So this time, instead of having just one predictor, we're going to have two. And we'll end up with an equation that looks like this. Our y hat is for salary is equal to our constant, our B0 or our y-intercept, plus the number of publications times our B weight for the number of publications, B1, plus the coefficient associated with time, which is B2, and the value of time, times the value of time or number of years of experience. So instead of before, remember we were calling it B1, now we have B2, and you can extrapolate that. We can go all the way out as far as we want. And in the stats textbooks, they'll indicate that with ellipsis and then X times B sub N or something like that to say like all the way out to N predictors. For just generally SPSS code, again, this is not what we study in this particular class, but I have it here for you for later. The way that you do this using SPSS is to just add a second predictor on the same line that you would have used where you would have had just one predictor before. So you just add one there. It's really simple. And here is what our multiple regression output looks like. And I'm going to go through these one by one. You're going to get one R squared value, even though you have two predictors. You get one F value, even though you have two predictors. And then you get one intercept, but two slopes. Because look, one intercept and two slopes. Dun, dun, dun. So thinking about R squared, the way we interpret R squared is actually very similar to the way we've done it before. It's the variance in the outcome that's explained by the predictors. I made this blue so that you'd see that it's predictors, more than one. So this is saying that 63% of the variance in salary is explained by the time since PhD and the number of publications. So the difference here, you still pull the same number, but the difference is that we're talking about the, you include both of these predictors in this model. So you say both time from PhD and number of publications. Now, just for fun, what I've done here is run separate regressions, one for each of these independently. So this one was just for publications. This one was just for time. And when publications is the only predictor, our R squared was 0.45. When time was our only predictor, the R squared was 0.58. But when they're together, the R squared is 0.27. 0.62. Oh my God. Sometimes I can't read. 0.63. Thank you. So it's different. The point, but it's also not 0.45 plus 0.58. Notice. It's not this plus that because these are not, these also share some variance. And I'll talk a little bit more about that in a moment. The next piece of this output we have is the ANOVA table. This is our overall, or sometimes they call it an omnibus test. An omnibus just means overall test. And this is the model fit as a whole. So how well does this model fit the data all together? So overall, do these variables do a better job of predicting the outcome than the grand mean model? But here's the only difference. Did I say this? Yes. There's one slight difference. Is that before, do you remember how we always had a 1 here because we had one predictor? So now we have 2 predictors instead of 1. So our numerator degrees of freedom is now 2. So the degrees of freedom from our regression equation is 2. And so that changes the math a little bit. I don't care if you memorize this, but it's here. And if you do the math, it will work. I promise. Look, I just did it for you, just so that you can see that it's there. So the reason that I bring this up is to show you that it's not exactly the same as it was before. It's a little bit different, but the principle is the same. So instead of being able to say this model fits better than the grand mean model globally, there's a little bit slightly different. You would say that on average, each parameter contributes to the model fitting better than the grand mean model. And that comes from having this in the denominator, the sort of r squared, and then having this, the number of degrees of freedom in the denominator. The model still does fit better than the grand mean model, but sometimes you'll see a non-significant f-test and it can be a little bit confusing. And the reason why you would see a non-significant f-test would be something like this. Not every variable is necessarily contributing to the better fit of the model, because you're dividing the error across two parameters. So now I've moved into the regression output, the coefficients, and this should feel really familiar because this is what we've done so far this whole semester. So for the intercept, it's the same as it was before. Remember, with a regression equation, the intercept is always the value expected when both of your x's are 0. Because it's when I plug in 0 for my x values. What's left is the y-intercept. So the interpretation of the constant here, 16791, is with 0 years from PhD, that's my x1, and with 0 publications, that's my x2. The expected salary is $16,791. Okay, and so that's the constant. So it's very much the same. It's just that you have to make sure you're talking about all of the predictors in the model instead of just one. Now the interpretation of the B weights is a little bit more complex than it was, but it's only a little bit more. And it's just like one little bit more, and it's the good bit. So let's talk about what that is. So I'm starting here with this part's the same. The expected change in the outcome for a 1 unit increase in x. Every time I increase x by 1, I'm expecting to increase y by this much. That's not new. What is new is you have to add when the other predictors are held constant, or when the other predictors are the same. There's a couple of different ways to say that, but the whole idea is that you have to hold one of them the same while you move the other one.
You stop.
Hi, I need you not to do that. Thanks. All right, so my B weight here for the number of publications, for predicting the weight, yes, number of publications is 316. So for this B weight here, 316, that is the expected change in salary for every additional publication. So that part's the same, but then we have to also add when we're holding the number of years from PhD constant. Another way to say that, which I think I do. Yeah. Another way to say that would be for any given number of years post-PhD, the expected gain in salary per publication is $316. So this first bit is about holding it constant, and the second bit is about the moving part. Or we can also say, after controlling for the effects of time on salary, the effect of publications is $316 per publication. My suggestion to you, I'm going to do one more. Here's another one that I really like and tends to contextualize this really nicely. Well, if you have two people who got their PhD the same year and who differ by one publication, they will be expected to differ in salary by $316. So my suggestion to you is just like save this, put it aside somewhere, and trade out the names of these constructs for your names of your constructs and your numbers. And one of them will probably make more sense than others to your brain. And use that one until that one feels really comfortable. However, I did forget about this part in all those interpretations. That number, $316, is not significantly different from 0. That p-value is equal to 0.261. And so while $316 is certainly doesn't feel like 0, it's so much error that we can't estimate that that's really a reliable estimate. It's basically, it's no different than if there was no relationship between publications and salary. Now we can do the same thing for the B weight for time. I'm going to put them all up here so you can see them. I'm just going to pick this last one because I really like it and it's different than the way we've talked about this before. This would be for any 2 people with the same number of publications, because now we're holding this one constant. 2 people who differ by 1 year post PhD will be expected to differ in salary by $922. And that is significantly different from 0. Our p-value here is 0.036. So we're interpreting them both the same way, but by switching up which one's which one's the focus. Both of them are correct. Neither of them is wrong. But one of them may be more narratively interesting to the story that you're trying to tell with your variables. Okay, here are my regression equations. This is the regression equation for this multiple regression here. Y equals 16,791 plus 922 times X plus 316 times X for publications. And this is just me pointing out to you that this is really different than when we ran these separately. When I ran a regression that only had time in the model, my y-intercept was 21,000 with $565 per year. Okay. So why are they different? I'll talk about that in a second. I went too fast. I already said this. This is making the regression equation. How do you do that? We have the y, we have the y-intercept, we have each coefficient for each predictor that you have in the model. And then just to go over one more time what controlling for means before I give you an example to work through. I think I'm going to do one more example first. Controlling for here, we're talking about variables that you're including in the model that are not necessarily central to your model. Might be a reason you'd call it controlling for. You might also call it controlling for a covariate. Sometimes a variable that's not of interest, but that might be related to your outcome and your predictors. So you want to make sure that you're not measuring just that. Why would you want to control for something? You would want to control for something if you have a variable that's related both to your predictor and your outcome, and it's not central to your theory. This is sometimes called the third variable problem. And so as you think about this output we were just looking at, if we're looking at salary, time, and publications, we have not accounted for everything that's predicting salary. We've predicted about half of the variance in salary. So what's something, take your chat box here and use it to type in something you think might be related to salary that's not in this model. Why might some people have higher salary than others that we don't have here? It's not time. Oh yeah, we got lots of good stuff. Oh, I love when I have people who studied higher education in these courses because you have such interesting insights. Yeah, we have a lot of potentially gender identity and race, your status. Yeah, historically, universities are not great at funding women and men at the same level, nor are they great at funding white people and non-white people at the same level. They just offer different packages. Personality, yeah, that's real. You just, Citizenship status. Oh my gosh, is that true? I don't even know. That's fascinating. Oh, that's awful. I'm having a hard time doing anything but thinking about America as being the worst right now. So I apologize that my political stance is showing here, but woof. Grant funds, definitely. One of the ways that we're incentivized is by any of these particular issues. I can go and say, look at all of the things I've published. You should give me another raise. So that's a personality thing too. So yeah, there's lots of third variables in here, but the ones that would be really important are ones that are related to time or publications. And so something that I could think of that might be related to either of those things would be like, well, time is a little bit weird because it just passes. You can't do anything with that. But the number of publications you get could be related to the kind of work that you do. That the kind of work that you do could also be predictive of your salary. And so if you want to be able to generalize across, say, qualitative and quantitative researchers, then you'd want to make sure you controlled for that in your model. But that's not the thing you're really interested in, but you need to control for it in order to be able to get at the pieces that you do. So that's what it means about holding people the same. All right. So I'm going to do one more example. And to do that, I'm going to just do it for you in front of you. And we're going to, yeah, age definitely affects both. Oh, I didn't mean to stop sharing. I meant to stop the slideshow. I will reshare just a moment. Okay, so I have this little data set that I got from the internet, which is not opening for me, and it's called cat personalities. Cat personalities, you say? What in the world could you possibly mean? I mean personalities of cats. Dun dun. Usually not, people aren't on mute and I can hear you laughing. So here we have, how many cats? This is a real life, actual for real research project. There's 2,800 people who have rated their cats on 52 personality traits. Yes, I agree with you. What? But if you have, I don't have pets, so I have not participated in this study. If anybody would like the information, they still are ongoing collecting data. You can put in the information about your cats and your dogs. So you can do that. So have a look at these. Can you see these traits of these cats that people have rated them on? So tense, deliberate, aimless, curious, anxious, all kinds of traits of cats. So what I'd like us to do is predict. We'll pick one thing to predict about cats, and we'll pick one or two things to predict them from. And so what I'd like to know is who has more than 2 cats in their house? Because if you do, I'm going to make you pick something for us to predict. You're kidding. Is everybody just afraid? All you're doing is picking. I'm doing all the typing. Don't be afraid. 2? Abby says she has 2. Okay, Abby, I volunteer you. What? Tell me about a cat. So I picked some random ones here, but I would be more fun to pick ones that are interesting. So, oh, there's 21. So it starts with vigilant, bold, clumsy. Anybody who sees something that strikes their fancy too. Abby, you get to pick the outcome, and then you can pick what you think will predict it.
Can we do inquisitive as an outcome?
Mm-hmm. Inquisitive 8. Okay, if I have an inquisitive cat, what's going to predict whether this cat is inquisitive? These 2,800 cats are inquisitive. I have clumsy. How about reckless, dominant? Oh. Ooh. We have defiant and we have curious and smart. I like it. So we'll go, I'll pull them all. Defiance, defiance, defiant.
Number 5.
Oh, bless you. Okay, defiant. Come here. Defiant, and then curious, which is 32. And smart. Yeah, just one. Smart. Where are my smart cats?
17.
There we are. Thank you. For the record, she apologized. She's just reading a really good book. Okay, so we're gonna run this analysis and see what we get. So we have 3 predictors. This is a multiple regression with 3 predictors. And the output is somewhere. Hello, come here. Oh, it's hiding behind you guys, so hang on. I have to move you. Okay, here we go. The first thing that we see is if we're predicting, oh my goodness, how exciting is this? This is great. I'm gonna hide our outcomes here. All right, so the first thing we have here is our R squared, which is the amount or the percent of variance in inquisitiveness that is predicted by being smart, defiant, and curious. Now, just thinking about these, what's your hypothesis about which direction these are going to go? Are these going to be all positive relationships, negative relationships? Are smart cats also going to be inquisitive cats? Or are smart cats going to be the opposite of inquisitive cats? Positive or negative? What do you think? Positive. Yeah, so we've got a lot of votes for positive. So this is, what did we just do? We said predicting how inquisitive a cat is from how smart, defiant, and curious they are. So the first thing we have is our R squared. I'm going to put, you know what I'm going to do is I'm going to pull these out. I want you to write up, what does this mean? I can like randomly die roll call you. My kid, they have these like sticks with everybody's names on them and they pull them out. But I don't really want to do that. I'd rather you volunteer. So while I'm pasting the output in here, somebody tell me what this R squared means. You can type it in or you can say it. Yep, we've got some good examples here. "45-ish% of the variance in a cat being inquisitive is explained by a cat's smartness, defiance, and curiosity." That's a much better than curiousness. Is curiousness a word? I think it's a word. Oh well. It is now. That's right. Okay, so now for our ANOVA, that's our F test. I'm gonna save this in the folder for you too, so you have it. So for our ANOVA table here, we see that there is a significant relationship. Notice the degrees of freedom here in the numerator is 3 because we have 3 predictors. Okay, so here for our smart, defiant, and curious as our predictors, it fits better than the grand mean model, or fits better. How have I been saying it in this class? Isn't that how I've been saying it? Fits better than the grand mean model? Yeah. The full model fits better than the restricted model. F equals 760. So here is, how do I know whether this model is fitting significantly better? I know because of this F test and the significance test. All right. Now, how did we do? This never happens. This is so exciting. No, doggone it. Where's my picture? All right, so here we go. We've got 1 intercept and we have 3 slopes. Our 1 intercept here is 0.936. I think I didn't tell you that these are all rated on a scale of 1 to 7. 1 being not at all like my cat and 7 being a lot like my cat. Okay, and so here what we have is that for when defiant and curious and smart are 0, our expected inquisitiveness rating for our cat is just about 1, which is significantly different from 0. So use this opportunity to write your regression equation. And I'm going to do the same thing. Y hat. Okay, so I wrote it like this. We have the y-intercept, and then making sure to multiply each of the coefficients here by its corresponding b weight. So that's how much we're weighting it by. And this is, remember, the reason that we're doing this is so that we can get an expected inquisitiveness score for any cat if we know their scores on these 3 things. So if the cat that sits on my front steps every day, I would rate him as a high defiance level because he just keeps sitting on my dang steps, even though none of us at this house like cats. He just sits there all the time. And we keep scaring it away and it keeps coming back. So it has a very high defiance score for me. So I would put him at like a 7. And maybe curiousness down lower, and smartness, I don't know how smart this cat is. Medium. I put it middle of the road because I don't know very much about this cat. So I can predict the inquisitiveness score for that cat because I know those other 3. So that's why you have to have both the weight and the thing you're multiplying it by in each one. Okay, so now everybody jot down, pick one of these coefficients to jot down, defiant, curious, or smart. And I'm going to pop you into your breakout rooms for just like 2 minutes to chat about what that means and how you interpret it. Okay, let me get my breakout rooms. Does everyone have something written down? Alrighty. Timer. Well, hi, you three who are still here. If you can hear me and you're here, we can chat about these ourselves instead of me going to a random breakout room. Did you pick one, Jamie?
Yes, I picked SMART.
All right, why don't you do SMART for me?
Sure. So I'm looking back at other examples.
Mm-hmm.
So for any given score in inquisitiveness, is that the noun we're saying? Inquisitiveness?
Yeah, inquisitiveness, that works. That's the outcome.
Yeah, so for any given, and it's scored on 1 to 7, right? So for any given score in inquisitiveness, the expected, I don't know, trait, would you expect that the trait in smartness, or I don't know, sorry, these are kind of hard to, would be 0.062? Is that kind of what's happening?
It's kind of what's happening, but you have them a little bit backwards.
Oh,
And so, so look at the equation here. Where are you putting in a number? Where are you plugging a number in to represent? That is a terrible question. If you're trying to interpret SMART, you're going to plug a number in here to SMART. And that number represents the cat's score on smartness.
right.
And so if I'm going to plug in a number here to smartness, if I plug in a 4 and then next I plug in a 5, those are 1 unit different. And so every time I go up by 1 on SMART, what happens to my expected Y?
I mean, I mean, it's a positive relationship, so it increases.
Uh-huh. So that Y hat increases by
the 0.62.
Yep. Oh, 0.62.
Oh, 0.62.
Mm-hmm. Yes. So this part is the same as it was in standard regression.
Mm-hmm.
What does it look like? What's new with multiple regression? Do you remember?
Wouldn't we have to say when controlling for deviance and curiosity?
Yep. Stop. I said stop. Okay. When controlling for defiance and curiosity. Yep, that's exactly it.
And Dr. Logan, in reporting in paper, like for reporting purposes, would you also need to make a statement about, a cat's level of smartness seems to predict, how inquisitive they might be? Would you then tack on the statement of when controlling for XYZ? Would that be like the complete kind of thing that you would? Okay.
You said this nicely, defiance and curiosity. And then the other thing that's missing here is T equals 3.82, P equals 0.00, P less than 0.001. Yeah, I liked that a lot.
Okay. I guess I'm just trying to think about what, like, the main takeaway would, and maybe it's all of it. Maybe it's all of you know, how it factors together. I'm just curious if the, you know, I guess when reviewers or other folks are looking, is all of, like, would I include all of this information when reporting results?
Yep.
Okay.
Now, before you dive too far down that road, so yes, you probably will. One of the reasons that we have this assignment coming up, we will look at everybody's published works that they've brought in to see how much it varies by field and how much it varies publication to publication. But yes,
Got it.
I'm talking to you specifically about the things that are necessary to report.
Great. Thank you.
Yes, you are welcome. The fact that everybody didn't come back immediately says to me that this was harder than it might have been.
Oh.
We got some folks. Maybe I should have done one and then walked you through the rest. Hello.
Oh, it's everybody.
Hello, my pretties. I've been looking
Yes.
for gender non-conforming collective nouns.
I can't believe you don't like cats.
I'm sorry, Logan.
I didn't know this about you. We were just talking about it in our breakup room. I was like, I'm gonna have to follow up with her about this. I'm so surprised.
No, I'm not a cat person. They know it too, and they're trying to convert me. Everyone that meets me is like, oh, hi.
Yeah.
Won't you be my friend?
Oh, you met my friend before, actually.
I will not be your friend.
Yeah.
You don't trust me. Oh, I don't blame you. I like dogs fine. We don't have any pets at my house. No pets. All right. So we had in the breakout room that I visited, which was the no breakout room. We talked about the SMART coefficient. So if you did SMART, you might have gotten something like this. Every time I increase SMART by 1, Y hat is expected to increase by 0.062 when controlling for defiance and curiosity. And then a second statement that we came up with here was that a cat's level of smartness seems to predict how inquisitive it would be, controlling for defiance and curiosity. Both of those are correct. Each of those is correct. Okay, is there a group that did curious and feels really good about it and feels like sharing it? Yes. All right, Shantanu, you're up. Tell us about curious.
Well, when you keep defiant and smart constant, then there is an increase in the inquisitiveness of the cat by 0.714 as predicted by how curious it is.
Uh-huh. And that other piece of that is T, goodness gracious, look at that T value, 43.419. P is less than 0.001. So this is a whole other way to say it. I did not give you this as an example, but this works just fine. You can say this, keeping defiance and smart constant. So you put that clause at the beginning of the sentence, which is totally fine to do. There's an increase in the inquisitiveness of a cat by 0.714, as predicted by how curious it is. Very nice. That's a nice pithy one. And then last we have defiant. Nobody picked the first one? Does anybody feel brave enough to just go for it? And it's fine if you get it wrong, because I can just fix it. That's why I'm here.
I can try.
Yes, go for it.
You can say when defiant is increases by 1, when defiant increases by 1, the inquisitiveness is increases by 048. At the same time, we are keeping curiousness and smartness the same, constant. Okay.
Yeah, that's really good. At the
Thank
same time, we're keeping curiousness and smartness constant. The only thing I'm going to add here is I want to add a significance test. So I want to make sure that we are telling the reader that this is different from 0 somewhere. And
Yeah.
it doesn't make, if I put it here, I think it would be confusing because it would look like it's referring to keeping smartness constant and how significant that is. So I'm going to try to put it right here by 0.048. T equals 0.42, no, 4.2, P less than 0.001. Okay, and all of these should be italicized, but I do a terrible job of it because Carmen doesn't let you, and so I got out of the habit. So these P values and T values should be italicized. Okay, so now we have all three, smart, curious, and defiant. We have all three of those defined. And I did the constant, which is when all three of these are 0, our expected inquisitiveness score is 1. And that is a multiple regression. Woo. Do you feel good enough to, let me just make sure what I have next. I think it might be a quiz. Yes, okay. The next thing I have is a quiz. Do you want me to do one more before I let you do a quiz on your own? Yes, I will post this page to Carmen as soon as I stop recording things. All right, we're gonna try it. We are gonna try it, and we're gonna do this multiple regression quiz. So for multiple regression, I have gone back to the graduate student survey. If you remember, that graduate student survey is an actual data about graduate students and their programs that they're in. This is the same quiz that you did for this week. And the programs they're in and their the age that they are, as I think it was Abel maybe said that a few minutes ago, that it was age, that age might be a predictor of something. And whether or not they have dependents. So they had to answer this question about how many dependents do you have? And so that would be like children. And the outcome here is the number of articles that they have published. So I have 1, 2, 3, 4 predictors in this model. These two, SBS and humanities, are the same as what you've seen before. SBS, PMS, and humanities. And so what I'd like for you to work on, I'm going to give you 5 minutes of quiet time with me not talking, but me here. And then after those 5 minutes, I'm going to break you into groups for 10 to go through these answers. Actually, while I do that, oh, I am screen sharing. I'm going to pause recording so that I can upload that document right now. All right, heading to a breakout room to discuss this. We are going to 9. Hello, my pretties.
Hello.
How's this feeling for you?
Making sense.
Yeah, we just had to go download the slides to.
Oh, sorry about that. I wish there was a way to share screen like into breakout rooms. Whatever. Maybe there is. I will Google it. Okay. Did you all chat about any of these already? Or I can share it with you if you want me to.
In the slides you got on Carmen, PMS is supposed to be SPB?
SBS.
Yes.
Mm-hmm. Where's the screen share button? Why did it go away?
Maybe it might be because you're in a breakout room. I'm not sure.
Well, that is annoying. Oh, there, it's right there. Here, nope. There we go. I will share it with you. All right, so then let's go through them. Did you all, was the regression equation pretty straightforward? Did you figure that one out?
Yeah.
Mm-hmm.
I know I got here really fast, maybe before you were able to coalesce around any particular questions that you had. So do you want to, Krista, it looks like you're holding it. You want to hold it up for me? I can just.
Oh, no, I'm not. I'm just holding a notebook that you won't be able to read.
Oh, okay.
You know what I should do? I should take off my background.
You don't have to take off your background. It's fine. I just wanted, I thought maybe you were holding it there to try and show us.
No, you believe too much in me. I didn't even think to do that. Did not even think to do that.
Okay. So from the regression equation, what's the intercept?
2.733.
That is it. The value of the intercept right there. Did somebody write a sentence of that they want to share too?
I did. A grad student in physical and mathematical sciences will on average publish 2.73 articles when age and dependence are controlled for.
Yes, except for the intercept, it has to be when age and dependence are 0.
Okay.
Does that distinction make sense?
Yep, it does. Thank you.
But the average number of articles published is 2.733 when all other factors are held constant.
Not quite.
But it needs to include the others being held at 0.
When they're 0. Mm-hmm. So if you look up at your regression equation, and I think you'll see why it has to be 0. If you have your regression equation written out there, it's only 2.73 when all of those x's you have are 0.
So it would be okay if I put when all factors are held at 0?
Yes. Uh-huh. So if you're trying to put an actual value on the y, like an actual number on the y, then you have to say what, like where all the other ones are. Does that make sense?
Yeah.
It does, yeah.
Okay. I'm just jotting that down because this is why I like coming into breakout rooms. I can hear what you have to say. You want to talk about the next one while I'm jotting that down?
Interpret the coefficient for SBS.
Mm-hmm.
So let me read the way I wrote this. I don't think. So I guess it would be when PMS and when HUM is held constant, age years are at 0, students in an SBS major program will have 3.911 fewer publications than the constant, essentially.
Yes. Your mic cut out for me in the middle of that, which is why you see me hesitating, is because everything I heard was correct, but I missed the very beginning of your sentence.
When we're talking about, I'm like looking at, okay, when SBS. So when humanities is held constant and age and dependence are 0, students in that program will have 3.911 fewer publications.
Yes, then what?
Than the constant.
Which is who?
Which is which is physical and mathematical sciences.
Woo! So for that one, you can just say, you said humanities held constant, age 0 and dependent 0. You can use the same for all of those if they're all 0.
Okay.
Will also work. You don't have to say both. Okay, how does that, because like I said, you can write this so many ways. Justin, did you have something different in the way that you articulated that?
So I was looking at the question, it said interpret SBS. So I said, when SBS increases by 1 unit, the average number of articles will decrease by 3.9 when dependence, age, and humanities are held constant.
Yep. That is true. What about Michelle? Did you have something similar or something different?
Yeah, so I had a grad student in SBS will publish about 3.9 when articles less than a grad student in physical and mathematical sciences when age and dependence are controlled for.
Yeah, that's exactly right. So Michelle got really specific, and I'm sorry, I'm using your names on your placards here. So if it's different, let me know, please. So Michelle said something very specific, which is focusing in on the contrast between SBS and physical mathematical sciences, which you can do in this case. You can't always do it. So the things that Krista said and Justin said, those both are really universal. You can say them anytime. And Michelle, your interpretation was much more specific, which is students in SBS will have almost 4 fewer publications than students in the physical mathematical sciences, holding age and dependence constant. Yeah. Okay, I'm gonna jump in another random breakout room and let you all talk about age.
Okay.
Thanks, y'all. Oh, 8 is empty. Okay.
I was forgetting about the outcome, the number of articles. Hello.
Hello.
Hi.
How's it going in here? Anything
think
feeling
good.
particularly wonderful or particularly awful?
I don't know.
I wouldn't say anything's feeling particularly awful. I just think we're kind of working through the last two because we just didn't have time in the room. Well, I didn't have time in the room.
Yeah, it was really fast. It's hard. Yeah. Zoom teaching is new.
Yes.
Go ahead.
For number 4, does that go back to the rural versus urban versus suburban comparison? So if we were to say that a student in social behavioral sciences is predicted to have 3.911 fewer publications than a student in physical mathematical sciences when age and dependence are controlled for? Yay, okay.
Well said. Very well said. You could say it in any of those contexts. I don't know what I was going to say there. Sorry, this is not my first breakout room of the day. So yes, that's exactly right.
Yeah. Okay. Cool.
Great. Well discovered. Oh, I did not hit start on my timer, so I think I'm going to head back out.
We've been in here for 11 minutes.
We've been here for 11 minutes. How do you know?
Because it says remaining, and it starts at 30.
Yeah.
Oh my gosh, awesome. Okay, 11 minutes feels like probably long. Did I say 15? I forget.
I don't remember.
I'll let y'all talk about age. You got to dependence really nicely. I'm going to visit one more place, and then I'm going to call everybody back.
Oh, good.
But first, I have to find the breakout rooms button. So you just pretend I'm not here.
Ready.
Good luck with
Okay, does someone want to try the last one now that we've gone over the 5th one?
Yeah.
If it's okay, I'm going to take a short break while we wait to be brought back in.
Sure.
Hi, Dr. Logan.
Hi. Yes, take a break. Hadley, always.
Okay, thank you.
How did it go, y'all?
Yeah, we finished them.
Mm-hmm.
Okay, awesome.
Yeah, and we just talked about why the number of article published increased with the number of dependents, because that sounds
right.
true.
I was wondering the same thing, because that definitely does not feel like an accurate representation of my life. That's actually why I put age in the model, is because I put dependence in the model first. And then it was positive, and I was like, well, maybe it's just people who are like older.
Yeah.
Oh, Fan says the same thing.
Yeah, and Jian, am I pronouncing the right name of you?
Yeah. Jihan.
Jian.
Yes.
You just mentioned maybe like the sense of responsibility, like we need to make more money.
Yeah, maybe it's like make more money, or I've thought about it like, you know, if I'm doing online school, I have to do one thing at a time. I can't make that choice. If my kid is doing one thing in the afternoon, I have to be working in the day. I don't know. It's a very curious finding, in my opinion.
Mm-hmm.
I wonder if any of our higher education scholars can shed some light on that.
Yeah.
All right, I'm going to pull everybody back. Thanks, guys.
Okay, bye.
I didn't have anyone summon me, which feels really good. I'm not going to lie. I'm going to not forget to share my screen this time. Okay. All right, everyone. Did anyone have any particularly confusing bits of that they would like to go over as a group before we move to something else? I visited 3 rooms and everybody was feeling pretty good about it. So wheat. Okay. So the next thing I want to do is I'm going to really quickly talk about model building.
Dr.
Before
Logan?
Yes.
We got a question from Hadley. Actually, we talked about this during our session. So we were curious whether age was centered as a variable. So yeah.
That's a really good question. And no, I did not center age. So that would be 0 years old. Yes, question about the regression equation.
So we're just trying to figure out, I think we got confused with when the categorical variables were entered in and like as a comparison, the reference group. So with y hat, is that, I guess when you're talking about that in more layman's terms, is that the number of publications for a PMS program student?
Something here is the predicted number of publications for a PMS student when these are all 0.
Right, the y-intercept.
The y-intercept is, yes.
Yeah. Okay, got it. All right, that makes sense. So it is, but that's what y hat is. Okay, perfect. Got it.
Exactly, y hat is equal to.
Got
it. When you've solved the equation, y hat will always be a spot on the y-axis, but it's equivalent to a spot on your line.
Right, I was just, yeah, but I'm just trying to, like what the variable, what y hat means, I guess, in this situation is the number of articles. You're predicting the number of articles for a person in that program, that PMS program.
You're predicting the number of articles, and then depending on what variables or what values you plug into the regression equation, it's for a different kind of person. So sometimes
y hat is just, so y hat and that is just number of articles.
Y hat is number of articles. Yep.
Okay.
Expected number of articles.
Right. Okay. Got it.
And so if I plug in a 1 for SBS, then I'm not predicting for PMS anymore. I'm predicting for social behavioral sciences now.
Got it.
And the same for humanities. You can do the same thing for dependents too. So most of the time we are predicting, if this is a 0, then we're predicting for someone who has no children. But if we have a 1 in this model, then we're predicting for someone who does have dependents. And so now I would like somebody in this chat who studies higher education to tell me how the heck do people who have children have 3 more publications than people who do not have children?
This came up for us, and we talked about some of the things that probably wouldn't, or at least in this regression, that wouldn't be talked about. So it could be things like time management, age. So perhaps you're a more mature student. Perhaps you are a student returning, like a returning learner that has some industry experience. That might give you some context to already have some research experience to do publications. So I think those were immediately, a lot of those would be the factors about the student themselves that in many cases might make you a more mature student that might just be more ready to get engaged in publication as a newer student or younger in their year.
So yes, except that the one of those claims I've already refuted
because of
in
age.
this model. Yeah, it's not age because I've controlled for age in this model right now. You can't, I'm sorry, you can't plug that in here because you will unplug something and then it will all stop working. Okay, so yes, we cannot include, so it's not just that they're older necessarily, but it certainly could be any of the other things that you mentioned. Someone, they have more work experience, they have more life experience, time management. Theoretically, I shouldn't be teaching and parenting at the same time. However, that is currently happening. Get out from under my desk. Oh my God. Like, why? Please take no as an answer. I'm not on that much longer. Please go plug it in literally anywhere else in this house. Thank you. It is not fake data. Gingy, I agree with you that it seems like it should be fake data, but it is not fake data somehow. This is real life. Maybe there's just things going on in these other areas I don't understand. Oh, you know what's not in here? Other areas of nannies. Yeah. What's not in here is the gender identity of the respondent. And there's a lot of research, I don't know if you've read, but I've certainly read some, especially recently, about pandemic parenting, is that moms are picking up a lot of that pandemic parenting. She is now out from under my desk. Okay. So there we go. There's a lot of really interesting third variable questions. You know, we've only explained 11% of the variance in the number of publications that are here. Somebody in this class is using this data for their school project, I think. School project? Good God. For the project for the course. So can investigate some of these questions further. Yes, thank you. Awesome. So, you know, we're all going to hypothesize about your data all week long. All right. So let me look here at what I have left. So the next piece that I have here, I don't think, I think we can get through a good chunk of this, and then I'll leave you with a quiz to take before the next class goes. Because all this idea here is multiple regression, and it's just building on it a little bit more to talk about building a model. So instead of just doing multiple regression in one shot, it might be really interesting to build a model in steps. And by that, I just mean, I'm gonna skip through here a little bit. We're gonna use multiple questions. So if you've seen a question that's phrased like this, after I've controlled for student SES, does the complexity of teachers' talk predict the complexity of children's talk? So in that way, what we're doing is we're building a model by saying, I'm gonna control for this, and then I'm gonna look at the relationship here. And so all that this next step is I've completely changed my mind. I'm gonna do the rest of this later. We're gonna do this all at the beginning of next week. We're all done. I know I can't actually feel your presences, but I actually am feeling your presences, and you're all done, and that's fine. We can be done for today. So you have all the information you need to complete the assignment that you have for this week, which is a multiple regression, at least 2 predictors. I don't care if they're continuous or categorical, your choice. Your assignment will be due on Friday. You will have a peer review this week. It will be due on Monday. This is a different discussion. I didn't update this slide from last week. I will open a discussion for you about the reading that I have given you, which is about multiple regression in steps, which is what I have not taught you yet. So you can chat with each other about how that's going and what you're understanding and not understanding. And then I will start this next class with this piece about multiple regression in steps. Okay, then that's all I have for you today. I don't have any exit tickets for you other than to say thank you for coming to my TED Talk. All right.
Thank you. Bye.
Yeah. Thank you much. I'll see y'all next week.
Thank you.
Thank you.
Thanks.
Thank you.
Bye, Dr. Logan.
Bye. Where's the stop recording button?